Hello and welcome everyone. Very happy that we're all together again. In this tutorial, we will continue illustrating the run out and the total run out tolerancing and their applications. So fasten your belt and let's get started. The aim of this tutorial is to discuss the different applications that we are using the run out control at which. Also, we will discuss the different applications we are using the total run out control at which. So let's go ahead. First of all, if we need to talk about the applications that we use the run out control at which, we find that we use the run out when we need to ensure that a rotating or a circular feature maintains proper alignment or concentricity relative to a reference axis or plane. So, when we need to control the deviations or the alignment of a feature with respect to a datum axis, in this case we use the run out control. Also, the run out control is important in applications where the axial alignment or the minimal vibration is critical for the functionality or for the performance or, for example, for the assembly of the mechanical components. And this is because for the rotating parts, when the features are not homogeneously distributed across a center axis of a plane, there will be vibrations or instability of the part while it's rotating. Also, the larger profile feature deviations with respect to a datum axis results in defects of the functionality of the part, as it cannot satisfy its functional requirement, and also it can affect the assembly of the mechanical parts. And for this purpose, we use the run out control in the applications or the mechanical parts that we need a minimum deviation of the controlled feature with respect to the datum axis, as the controlled feature is critical for rotation with respect to the datum axis in this case. And for this purpose, we find that the first application that we use the run out control at which is the shafts and the automotive transmission, like this one here, as in the automotive transmission we use rotating shafts. Hence, we need to ensure that the surface of those shafts are having the minimum value of deviation with respect to the rotating axis. And this is to avoid the instability or the deviations of the part while they are rotating. Very good. Also, another application that we are using the run out control at which is the tool holder of the CNC machine, like this part here, as this is the holder that we use to hold the cutting tool of the CNC machine at which, and we use the run out control at this case as we need to control the deviations of the profile of those parts along its axis or along the axis of rotation. Also, we use the run out control for the rotating pulleys like those ones, and we use the run out control for this type of pulleys to control their profile deviations with respect to its axis of rotation. And this is for the same reason, as its profile is rotating around its axis of rotation, hence we need to have a stable rotational movement to control its surface. But now we need to know what are the applications that we use the total run out control at which, or what are the differences between the run out control applications and the total run out control applications. And the answer of this question depends on the difference between the run out control and the total run out control. As we learned it before, the total run out control is a more precise type of control, or it produces less deviations, or it produces more precise controlled surface, On the other hand, the run-out control is a less accurate type of control as it's used for the special applications or the applications that need higher level of accuracy or higher level of precision. And this is used with the critical applications, not the ordinary applications. And for this purpose, we find that the total run-out control to cost much more than the run-out control. And this is because it needs more precise machining operations and more precise manufacturing tools to achieve this higher degree of precision. And one application on the total run-out control is the precision peerings, like this one, as peering is a rotating element that has a critical function for rotation. So we use the total run-out control on it for controlling its surface and its pole peerings using the total run-out control. Also, we use the total run-out control in the high-speed spindles manufacturing operations, and this is because the high-speed spindles need to be rotated in a very high speed, hence it needs an accurate and precise surface with respect to its axis of rotation. And this is to decrease the vibrations of the spindle as much as possible when it's rotating. So we need the spindle to be stable mechanically as much as possible, and this decrease of the vibrations is done by applying the total run-out control on the surface of those spindles with respect to its datum, which is the axis of rotation of the part. And by the same way, another critical element that we use the total run-out control at which while the manufacturing process is the rotor assemblies in the gas turbines. And this is because the rotor of the gas turbines is rotating in a very high speed with a very larger power. Hence, we need it to be stable as much as possible, and for this purpose, we control its surface using the total run-out control to get a very high precision or a very high accuracy. More than great. So that's about this tutorial. Hope that's clear right now. Thank you for watching and see you next tutorials.